Hello there. In this video, we will be learning about the law of equipartition of energy. Now, this law of equipartition of energy states that for a system in the thermal equilibrium, the total energy is distributed equally among all its available degrees of freedom. So, based on this law of equipartition of energy, now let's try to find an expression for the average total kinetic energy for a system with F degrees of freedom. For a monoatomic ideal gas, the average kinetic energy equation is 3 by 2 kBT, where kB is the Boltzmann constant and the value of it is 1.38 times 10 raised to the power minus 23 joule per Kelvin. Now, this particular equation, that is 3 by 2 kBT, tells us about the average kinetic energy for a monoatomic ideal gas. Now, the degree of freedom for a monoatomic ideal gas is 3. That is, it has 3 translational degrees of freedom in x, y and z axis, and in the rotation and vibration, the degrees of freedom for a monoatomic ideal gas is 0. We can say that the 3 degrees of freedom are corresponding to 3 by 2 kBT average kinetic energy. So each translational degree of freedom will contribute this much divided by 3. So we can say that the energy contributed by each translational degree of freedom would be equal to 3 by 2 kBT divided by 3. That would be equal to 1 by 2 kBT. Now please remember, this is the energy contributed by 1 degree of freedom. So if a system has F degrees of freedom and each is contributing, the one that we just said, that each is contributing 1 by 2, that is half into kB times T, then the total average kinetic energy equation, so we can say E total. So if the system has F degrees of freedom, it would be F times of this value. So F times of half kBT, where F is the degrees of freedom of the system. Let's sum up the degrees of freedom for different types of molecules with respect to number of atoms. So we can write here as number of atoms, and here we can write the degree of freedom, and in the last two columns we can also see the variation with respect to temperature. Now let's say if the temperature is less than 70 Kelvin, then the situation would be something different, and if the temperature is greater than 3000 Kelvin, the number of degrees of freedom would be different. Now generally when we talk about the degrees of freedom, we mostly talk about the degrees of freedom in the translational plus in the rotational. So first let's understand with respect to the different number of atoms. Let's say a molecule only contains a single atom. In that, the degrees of freedom would be 3. That is, it will have all the 3 degrees of freedom in the translational. In the rotational, it would have 0 degrees of freedom. For a diatomic gas, the number of atoms would be 2. So the degree of freedom in that case would be 5. That is, it would have 3 degrees of freedom in the translational, and in the rotation, it would have 2 degrees of freedom. Now, for a polyatomic gas, let's say if the number of atoms is 3, then the degrees of freedom in the translational, it would be 3. Also in the rotational, it would be 3. So in totality, it will have 6 degrees of freedom. Now, these are the degrees of freedom that you need to remember, and these are the most important. But also, we need to understand how these degrees of freedom would be affected if we take temperature into the consideration. Now, if the temperature is less than 70 Kelvin, then the only degree of freedom that we need to take is the translational degree of freedom. All the other degrees of freedom we don't need to consider in this situation. So we can say if the temperature is less than 70 Kelvin, if the number of atoms is 1, it will only have the 3 degrees of freedom. In this also it would have 3 degrees of freedom. In this also it would have 3 degrees of freedom. The temperature is greater than 3000. We also have to consider the degree of freedom in the vibration. Now, for vibration, when it comes to a molecule having just one atom, that is a monoatomic molecule, the vibrational degree of freedom is 0. So we can say that in this particular situation, the total degrees of freedom would be 3 in the translational, 0 in the rotational and 0 in the vibrational. So the total comes out to be just 3. When it comes to the polyatomic molecules, that is the one that contains more than one atoms, the number of degrees of freedom in the vibration is given by the formula 3n minus 6. Now 3n minus 6 is a formula of the number of vibrational degrees of freedom when the molecule is non-linear. And when the molecule is linear, then the formula becomes 3n minus 5. This happens when the molecule is linear. So let's say we talk about a non-linear polyatomic molecule. So in that particular case, the total degrees of freedom would come out to be 3 in the translational plus 3 in the rotational, and this is when the temperature is greater than 3000 Kelvin, plus we can say 3n minus 6. So as you can see, 3 plus 3 is 6, it can be cancelled with this, so the answer would be 3n. So the total number of degrees of freedom for a polyatomic non-linear molecule would be 3n. So I hope you are now familiar with what is the law of equipartition of energy, and we also got an expression for the average total energy for any system with f degrees of freedom. See you in the next video. Till then, bye bye.